In this video, we will start to study the events that can be defined at the smart device objects level in an online application. That is to say, when connectivity is required. However, first of all, we will mention the differences between an offline application and what we will study here. Some events will be run on the client. For example, system events such as the new client start or back. Also, there are other events such as user events and events associated with controls, including those predefined by the work with pattern. We also have the system events that we already know, start, refresh, and load, that will be run on the server as long as it's an object that requires an internet connection. Then, we will see what happens with these events in an offline architecture. But for now, we can say that they will be run on the client. When the main object of the application is involved, we will also have the new events: flip.start, split.start, slide.start, cascade.start, and tabs.start that we saw when we studied the application's navigation style. They're valid for the main object, regardless if it's a dashboard or not. Events run on the client will have a reduced grammar compared to that of events run on the server. We will talk about this grammar in another video. In the example, the insert event of the list is an event created by the pattern. Also, the pattern automatically set the default action property with the default value. It indicated that even if we didn't see an associated event, the detail was called in view mode when the user tapped on a line of the grid. Here, we change this behavior because we program it through one of the control's events involving touchscreen use. For example, the tap event on the image called arrow. All these events belong to the client, even if they invoke objects that call services, data providers, in the server to return or save data. On the other hand, the load event to load the grid lines will be executed on the server if the object runs online. Here we see the layouts created by the pattern for the general section and the default events. There are 4 of them. 2 of them apply to the edit mode, and the other 2 to the view mode. They will also be client events. Note that the composite command appears, and we will study it later. Also, in the save event, we can see the external object SDActions. It's located in the APIs folder, about which we will talk later. What it does is encapsulate the call to the REST business component located in the server, in order to save the speaker's details in the database. Let's talk about the system events run on the server in the context of an online application. What happens when we invoke the sessions list from the dashboard? In the client, this list runs the client start event. Next, it makes an external call to the REST service that will return the data from the fixed part of the panel. It will be a data provider automatically created by GeneXus. Even though it isn't visible in the KB, it'll be displayed in the navigation list under the name Work with Devices, transaction name, work with level in question, and node where we're positioned. In this case, it'll be Work with Devices Session transaction name, session level name, and list, node that we're invoking. This data provider is run on the server, and the start and refresh events are executed within its internal logic. The database is accessed if necessary. The database finds the records and returns them to the data provider. In its response, it returns the data to the part of the application running on the device, the work with that called it. This work with looks for the required images and, with the response received, draws the user interface corresponding to the fixed part of the work with list. In this case, it didn't require data. Next, the previous steps are repeated, but now the data provider automatically created by GeneXus and transparently for us is called to return the grid's data. Its name will be Work with Devices, transaction name, level, node, grid. In this case, it'll be this one. Internally, this data provider runs the load event for each grid line to be loaded. Once the application running on the device receives the response with the grid data, it draws the user interface corresponding to the grid. In sum, on the client side, the device, we have the dashboard event that is activated when we tap on the image, an invocation to the work with sessions list. The corresponding code runs on the client, which starts to run this list. In its internal logic, this work with runs the client start event. Next, it calls the server to have it return the data to load in the fixed part through a REST service. Next, it asks the server to run the other REST service, the one that returns the grid data. With the data returned in two responses, it draws the screen, the fixed part on one hand and the grid on the other. We're assuming that there is no caching to simplify the explanation. We're not focusing on the grid's paging either, which is also made. The data provider that runs the load does it with paging, that is to say, it only returns X records at a time. The start event is only triggered the first time. It isn't run again unless the user exits the panel and enters it again. The load event in the web panel is run n times, if the grid has a base table, as in this case. So, we can consider the difference between a smart device panel, such as the list or the detail, and a web panel. In the smart device panel, the fixed part and grid navigations are separated, and the screen corresponding to the fixed part is drawn independently from what happens in the grid. This has consequences. Suppose that we want to show the number of sessions in the sessions list. If we program this panel as a web panel, we would add a total variable that we would add in the layout outside the grid. We would load it in the load event, assigning it the value that it has, +1, and we start it in the refresh event, F5. But it's showing us 0. Why is that? Here we can see an outline of what we've done. The problem is that we programmed this panel as if it were a web panel, ignoring the fact that the screen corresponding to the fixed part will be drawn in the device before calling the data provider that will return the grid lines, to draw it later on the screen. Therefore, when the total variable is displayed, the load event that increases it will not have been invoked n times, and the grid will not have been drawn either. Note that this is the cause of the problem that arises, not the fact that the refresh and load events are separated in two programs, two independent data providers. This separation is transparent for the developer, and what is done in the refresh event will be seen by the load event. There is another problem with caching, and you can read about it in our wiki. Therefore, in order to show the number of records, a solution is to program a for-each command that calculates them within the refresh event. The for-each command base table will be the table associated with the first level of the session transaction. To that table record, the value of the total variable will add 1. We remove that assignment from the load event and press F5. If we look at the navigation lists, we can see that for the session list data provider corresponding to the fixed part of the list, we have the for-each command that we've just programmed, which will run through the session table counting the records. Once this data provider is triggered, the fixed part will be loaded, and then the total variable will have the desired value. Let's look at the other data provider corresponding to the lines, also going over the session table.
Veámoslo en ejecución. Ahora la variable total está mostrando el valor 9, que coincide exactamente con la cantidad de registros contenidos en la tabla.
The system's load event doesn't require any special consideration because it's similar to the load event of a web panel. And since several grids with base table can be included in the same layout, just as it happens with web panels when we have more than one grid, we will have to indicate the grid of the load event we're programming. Instead of writing event load, we type event, grid name, period, load. Here we show the load example to load the grid items from the Work With Devices session list. This event is run on the server, and that's why it can use all the attributes of the extended table. Note that the getSessionTracks procedure doesn't have to be exposed as a REST service because it's invoked from the server itself. So, now we've talked about events run on the client and events run on the server. It's important that we differentiate them because what we can program in the client events uses a more reduced grammar than what we can do in the server, as we will see in another video. Note that this will not affect the implementation of an offline app. That is to say, when it comes to grammar, you will program events in the same way regardless if your application is online or offline. It's transparent in this sense. In the next videos, we will continue studying aspects related to events, such as APIs to, among other things, integrate with the native functionalities of devices, execution order of events, grammar of client events, and so on.